What's going on, everyone? Welcome back. Patrick here, and moving on to the next video on limits at infinity. We got these three limits to solve over here. So if you notice, these are pretty complex limits. And before getting into these, I want to make a note that I'm assuming before you watch this video that you've watched the previous videos on limits at infinity. Because in those previous videos, I've introduced a lot of properties, a lot of different methods that I'm going to be using in this video. So all that stuff is carrying over. And I'm also going to be introducing methods in this video that I'm going to be using in future videos. So make sure you're watching these in order. So starting with number one, we got the limit as x approaches infinity of the square root of 2x to the 4 minus 5x squared all over x minus 3x squared. So if you remember, with something like this, what you want to do is divide everything by x to the power of the highest power in the denominator. And notice the highest power in the denominator is what? It is x squared. It's this 2 over here. So what we would do is we would let's start with the denominator actually first. So we would take this x divided by x squared. We would take this 3x squared divided by x squared. And then we would take this entire square root, 2x to the 4 minus 5x squared, and divide all of that by x squared. Notice that this here is an entire expression. We can't split up the square root. So if you have the square root of a minus b, that doesn't equal the square root of a minus the square root of b. Or if you have a plus here as well, so it's plus or minus. If you're multiplying, then you can split them up, but not if you're adding or subtracting. So we have to take this entire expression and divide it by x squared. Now, what's the problem here? The problem is, how are we going to take this entire expression under the square root and divide it by the x squared? That's kind of what's new in this limit, because before we had another polynomial up here without any square roots. Or if we did have square roots, it was just single terms, like the square root of x. And we could divide this by x squared. That's pretty simple. But what if we have these multiple terms here? Well, what you want to do with this square root first, so let me write this over here, is you actually want to rewrite it where we're going to factor out that highest exponent like we were doing in the previous video. So an example of a method that's going to carry over to this one. So if you remember in that video, what we did was we first factored out the x to the power of the highest exponent of this term here. So forget about this limit here for now. I'm just dealing with this. I'm just going to deal with this numerator. I'm going to rewrite it. So if I factor out an x to the 4 from 2x to the 4 minus 5x squared, what would be left in the bracket? Well, we're divide by this by x to the 4, divide by this by x to the 4, so we'd be left with 2 minus 5 over x squared, like that. Okay, so this is the same as this. And then what happened? Then we split up the square root. So we split up this to be x squared. The square root of x to the 4. And then we split up this, like that. Because we're multiplying two things here. If you remember, if you're multiplying, you could split up those square roots. That's a valid thing to do. And then the square root of x to the 4, that's like x to the 4 to the power of a half. Notice that that ends up being x squared. And then this we're just going to leave as is. 2 minus 5 over x squared. So this here is the exact same thing as this. And again, I went over this in a little bit more detail in the previous video of how to go from here to here. But we were just dealing with this in the previous video. We weren't dealing with this part of a rational function. So notice we're going to have this here. We're going to have this where we have multiple expressions like that. So this, these limits are a little bit more complex. So we know that this here is equal to that. And so what's nice now, let's continue this, is we'll have the limit as x approaches infinity. Instead of writing this square root, I'm going to write this here, that final result, where we have x squared over 2 minus 5 over x squared. And remember, we're dividing all of this by x squared. So that entire numerator, we're dividing by x squared. Over, let's simplify these here. So x to the 1 over x to the 2, that's just 1 over x. Minus x to the 2 over x to the 2, those cancel out. And we're just left with a 3 there. And notice now what's happening is this x squared and that x squared cancel out. And so what we're left with is the square root of 2 minus 5 over x squared all over 1 over x minus 3. So this is the exact same expression as this. We just sort of manipulated it. And on the side, we manipulated this numerator from this to that using the tool that I introduced in the previous video. And in my opinion, that's the best way to go about it. Now, sometimes you'll see a textbook going from this numerator to this numerator, and what they're doing is they're dividing by x squared, but instead of dividing by x squared, they'll like divide by the square root of x to the 4, which is the same as x squared. And when they divide by square root of x to the 4, then they could take that and sort of distribute it into that square root. But personally, I don't like to do that. I think that can get pretty confusing. Initially, I was actually going to explain it like that. So you may see your prof do it this way. You may see your textbook do it this way. In my opinion, I think it's better to take that and rewrite it as this first. Take out that x to the power of highest exponent, and then square root that x to the power of highest exponent, and just simplify to that using the tool that I used in the previous video. So I wanted to mention that sometimes profs, some textbooks will go to here using a different method. Instead of dividing by x squared, they'll be dividing by x to the 4. And so what that allows you to do is under the square root, it allows you to divide the 2x to the 4 by x to the 4 and minus 5x squared by x to the 4. And then notice that you'll end up here, right? In my opinion, it's not the best way to go about it. I think it's better to factor out like this. But either way, as long as you're getting to this same numerator, whichever method you're doing, whichever method you're comfortable with, just make sure you're getting the correct answers. So if you are using that method, the other method that textbooks show, that certain profs show, on these, just make sure you're getting the exact same answer that I'm going to get. Okay, so we're here, and now notice that we could plug in infinity for all these. So notice that 5 over infinity squared, that's going to be 0, so we'll end up with square root of 2 minus 0 over 0 minus 3, because this is going to go to 0, 1 over x, 1 over infinity. So 2 minus 0 is 2, square root of 2 is just square root of 2. You can't simplify that any further. So square root of 2 over negative 3, let's bring the negative up top. I'm going to write this a little bigger here. So you'll end up with negative 2 over, negative square root of 2 over 3. So that there ends up being the final answer for this limit over here. So whenever you see something like this, a square root with multiple expressions in it, you want to use the same method I introduced in the previous video and rewrite it in this kind of format. It's exactly what I'm going to be doing with this expression and with these two expressions separately. I'm going to be factoring out first and then using that method where we're going to be dividing by that highest exponent in the denominator. And then moving on to number 2, this limit over here. Notice that I erase the third limit just to give myself more room for this one, and then I'll rewrite the third limit once we get to it. So we got the limit as x approaches infinity of 5x to the power 3 minus 2x squared all over the square root of 125x to the 6 minus 3x to the 3 plus 2. So notice in the previous one, we had in the denominator, we had x minus 3x squared. And so what we did was we divided everything by x squared, and then we divided that numerator, that square root, by x squared. But notice here how in this denominator, we don't have like a regular polynomial function. We have that expression with a square root there. So what we got to do is take that square root and rewrite it in that previous format where we're going to be multiplying by 2 factors. Okay, so what I'm going to do is, so the numerator is going to stay the same. Actually, you know what? Before we do that, what I'm going to do on the side here is I'm going to take this denominator and convert it to that format where we're multiplying. So what we want to do is first factor out x to the power of the highest exponent here. So we're going to take out x to the power 6. Notice 6 is the highest exponent. What would we be left with? We'd be left with 125 minus 3x to the 3 over x to the 6 plus 2 over x to the 6. And then this, we divided by x to the 6, the x to the 6 is canceled out, so we're just left with 125. And if we simplify this here, we'll have x to the 6, 125 minus x to the 3 over x to the 6 would be 3 over x to the 3 plus 2 over x to the 6. And then what can we do here? Then we split up. Remember, we're multiplying this by that, so we could split this up to be the square root of x to the 6 times the square root of 125 minus 3 over x to the 3 plus 2 over x to the 6, like that. Square root of x to the 6 is like x to the 6 to the power of a half, which is x to the 3. And then this is just going to stay the same. We can't do anything else about that. Okay, so this expression here in the denominator is the exact same as this. So what we want to do now is let's rewrite that numerator. We got 5x to the 3 minus 2x squared. And we're going to put it all over. Instead of writing this, I'm now going to write this here. X to the 3 square root of 125 minus 3 over x to the 3 plus 2 over x to the 6. And now what we do is now we can divide everything in the numerator and the denominator by x to the power of the highest exponent. And x to the power of highest exponent in this case is x to the power of 3. Now this here is one whole expression because we're multiplying these two things. So we're going to divide that whole expression by x to the power of 3. And then we're going to divide this by x to the power of 3 and then this by x to the power of 3. So I want to make a couple of notes. The first note is, notice in the first limit what we did was we first divided by x squared. We divided everything by x squared, the numerator and denominator, all the expressions in both of them by x squared. And then we converted that square root into this kind of format. But notice with this limit, because that expression with the square root was in the denominator, we had to convert that first, and now we were able to tell what we were going to divide by. We were going to divide by x to the power of 3. Divide everything by x to the power of 3. And then another thing I want to mention is how this here is one expression. So we're not going to be taking this x to the 3 divided by x to the 3 and this square root divided by x to the 3. We divide the whole thing. So like if you have AB over C, that does not equal A over C times B over C. All right? You got to divide only one of those things by C. But if you had A plus B over C, that would equal A over C plus B over C. So if there was like another expression out here, if we had like plus, I don't know, let's say 5, then the 5 would get divided by x to the 3 as well. Okay, but here we're having two expressions that we're multiplying. Okay, so we don't divide both of those expressions by that C value. We just divide the whole thing. We divide one of them by x to the power of 3. Okay, so thought I'd make a note of that. And then from here, what we can do is we can just simplify these. So x to the power of 3, x to the power of 3, those cancel out. So we got 5 minus x to the power of 2, x to the power of 3. That would simplify to 2 over x. Because there's 2 x's up top, 3 x's at the bottom. So there's one x left at the bottom. And this is going to be all over. Notice this x to the 3, that x to the 3 cancel out. So this would end up being 125 minus 3 over x to the 3 plus 2 over x to the 6. So this is the exact same thing as this. Both of these expressions are exactly the same. And now what we could do is we could plug in this infinity, because notice all of these things that have a constant over x to the power of a rational number, all of those are going to go to 0. Another thing I want to mention is that I mentioned it in the first limit. Textbooks, certain profs may go from here to here using a different method. So instead of factoring out that x to the 6, that square root of x to the 6, which is the same as x to the 3, they'll like divide this by the square root of x to the 6. So they'll divide all of these by the x to the 6. It's just weird. It's just weird, in my opinion. I prefer this method. I feel like the steps are more clear. It may actually take a little bit longer using this method, but I feel like everything's a little bit more intuitive. The steps are more clear, and so you'll get through these limits in a much smoother, a much nicer way. Okay, so now, as I said, we could plug in this infinity. This goes to 0. This goes to 0. This goes to 0. So what are we left with? We're left with 5 over the square root of 125. Because we'll have 125 minus 0 plus 0. So we're just left with 125 there. So this limit, it's equal to that. And notice that this here you could simplify further. So you always want to see if you could simplify, especially with these limits with square roots. You may lose marks if you don't simplify this. Or you may look in the back of your textbook, see a different answer, but the answer is going to be the same. Like, if you do see a different answer with a square root in the back of the textbook, what you want to do is you want to just make sure you want to get the decimal of that value in the back of the textbook, get the decimal of what you got. If the decimals are the same, then you actually got the same answer. You just maybe didn't simplify further. And this we can simplify further. We can rewrite the square root of 125 as a square root of 25 times the square root of 5. Square root of 25 is 5. So 5 root 5 is the same as square root of 125. Notice the 5's cancel out. So we're left with 1 over root 5. And then if you don't want to have a square root in the denominator, you could rationalize this by multiplying by square root of 5 times square root of 5, and you'll end up with the root 5. Square root of 5 times square root of 5 is 5. So this, and this are the exact same answers. They'll all give you the same decimal, and your textbook is most likely going to show this answer. over here. But sometimes they'll show this answer. They'll allow square roots in the denominator. Some profs, some textbooks want you to rationalize, so they'll show that. But either way, one of these three answers, that's the answer to this limit. And then finally, number 3, we got the limit as x approaches negative infinity of 5x squared all over the square root of 2x to the 4 plus 1 plus the third root of 27x to the 6 minus 1 plus x. So this is a fairly complex one as well. Now, as usual, what we want to do is we want to divide all of the expressions by x to the power of the highest exponent in the denominator. Problem is, it's kind of tough to tell at this point what is the highest exponent because we got these square root. We got this square root here and we got this third root. And we got multiple expressions under that. So what we got to do is we first have to convert these two expressions to an expression where we're going to be multiplying, where we have x to the power of something on the outside of the square root. So I'm going to be using the exact same method that I've been using in this video, in the previous 2 limits, and in the video before. So first thing I'm going to do is work with this square root of 2x to the 4 plus 1. Notice that we could take out an x to the 4, so we'd be left with 2 plus 1 over x to the 4. So this and this, exact same thing. Then distribute that square root of x to the 4, and then we got 2 plus 1 over x to the 4. And then the square root of x to the 4 is what? X squared. And then this here we would just leave as is. Okay, so let's actually start rewriting this limit. So we got the limit as x approaches negative infinity. We got this 5x squared up here. And then this square root of 2x to the 4 plus 1 is the exact same thing as this. X squared times 2 plus 1 over x to the 4. And then what we got to do is the exact same thing, but with this expression, this third root of 27 x to the 6 minus 1. So what we do is third root, we take out an x to the 6, the highest exponent, which is 6 in this case. So we take out x to the 6, we're left with 27 minus 1 over x to the 6, like that. Then we split these up, so we got the third root of x to the 6, got the third root of 27 minus 1 over x to the 6. And then this here, this third root of x to the 6, that's the same as x to the 6 to the power of 1 over 3, which is 6 times 1 over 3 is 2. Right? So this is the same thing as x squared. And then this here we would leave as the third root of 27 minus 1 over x to the 6. So this expression, this here, this is not 3 times, by the way. It's the third root. That 3 was a little large. This expression is the same as this one. So we'll have x squared times the third root of 27 minus 1 over x to the 6. And then we have the plus x. So notice in this case, we have 3 different expressions in the denominator versus in the last limit, in limit number 2 that we worked with, it was just one entire expression, kind of in this format. But we're multiplying 2 expressions here, which is like one expression plus another expression plus another one. And so what we want to do is we want to look at these x values now and see which one has the highest exponent. So we have x to the 2, x to the 2, and then we have x to the 1. So what's the highest exponent? It's 2 in the denominator. So now what you want to do is you want to divide everything by x to the 2. Remember, we divide this whole thing by x to the 2, divide this by x to the 2, divide that by x to the 2. and we got to divide the numerator by x to the 2 as well. So notice now we're dividing multiple expressions. Now, if we had if this ended up being maybe, let's say, x to the 5, then 5 would be the highest exponent. So we'd be dividing this by x to the 5, this by x to the 5, this by x to the 5, this by x to the 5. But we ended up getting a 2 over here, and both of these were the same. So dividing everything by x to the 2. And now what happens is we can simplify this. Notice this cancel out, so we're just left with a 5 up top. Notice this and this cancel out, so here we'd be left with square root of 2 plus 1 over x to the 4, plus this and this cancel out, the third root of 27 minus 1 over x to the 6, and then this and this, x over x squared, that simplifies to 1 over x. And now what we can do is we can simply plug in negative infinity, because notice how everything now is in the format where we have a constant over x to the power of a rational number. And we know the limit as x approaches infinity or negative infinity of that format, it's going to equal 0. So notice this here is going to go to 0, this is going to go to 0, and then this whole thing is going to go to 0. So we would end up having, I'm going to erase a little bit here, we would end up getting 5 over 2 plus 0 is just 2, so we'd end up with the square root of 2, plus 27 minus 0, that's just 27, so we'd have plus the third root of 27, and then this is just 0, so this would be like a plus 0 over here. And so notice we could simplify this further. We got root 2 plus, what is the third root of 27? That's just 3. So that simplifies as well, and then the plus 0 we wouldn't write. So if you want to make this look nicer, 5, you can put the root 2 in front. I usually like to put single constants in front, so 5 over 3 plus root 2. Now what if you don't want to have any square roots under the denominator? You could rationalize this. Notice that this is a 2 term here, so you'd have to rationalize it by multiplying by its conjugate. So you'd multiply by 3 minus root 2. So you'd end up with 5 bracket 3 minus root 2 over 3 times 3 is 9. Root 2 times root 2 is just 2, so we'd have minus 2. So you would have 3 minus root 2 over 7. Another thing you could do is you could distribute this 5 inside the bracket, so it could be 15 minus 5 root 2 over 7. So this, and then this, or this right here, they're all the exact same thing. If you plug all those in your calculator, you would get the same decimal. Just let me make sure that everything is all good here. Yeah, it looks all fine. Right? So again, just an example of where your textbook might show this answer and you end up over here. So you might look at this and be like, no, that's totally wrong, but it's not. It's the exact same answer. It's the exact same decimal if you plug them both in your calculator. It's just they rationalize this by multiplying by the conjugate, or they'll keep the 5 outside. In my opinion, I would say this one is probably the nicest. It kind of has the least amount of stuff, either this one or this one, versus these. But again, sometimes they require you to rationalize, not have any square roots in the denominator. So just be on the lookout for that.